On a cold morning in January 1832, a jeweler named Matthias Baldwin stood in a Philadelphia workshop watching steam escape from a brass valve. He had never built a train engine before. Within 100 years, his name would be stamped on machines that move an entire country to war. If you find value in stories like this, stories that discover the machinery behind history, consider subscribing. These aren't just tales of metal and steam. They're about the people who build impossible things. The story of Baldwin Locomotive Works is not a story of genius alone. It's a story of 20,000 hands making 70,000 machines across 130 years of American history. And when the world went to war twice in one generation, those machines became more than train engines. They became lifelines. Philadelphia, 1831. The Industrial Revolution had arrived in America, but slowly. Trains were still experiments. Most were brought from Britain. Matthias Baldwin was a jeweler by trade, skilled with small gears and delicate springs. He had no official engineering training, but he had precision and he had curiosity. In 1831, Baldwin was asked to build a small stationary steam engine for a local museum exhibit. It worked. Crowds gathered. A few months later, the Philadelphia, Germantown, and Norristown Railroad approached him with an unusual request. Could he build a train engine? He said yes. He had 6 months. On November 23, 1832, Baldwin's first train engine, named Old Ironsides, completed its first journey. It traveled 6 miles in 58 minutes, pulling 2 carriages filled with passengers. The engine weighed 5 tons. Its boiler pressure was 100 pounds per square inch. It burned anthracite coal, a Pennsylvania resource that would define the region's industrial future. According to records saved by the Railroad Museum of Pennsylvania, Old Ironsides was not the fastest or most powerful train engine of its time, but it ran reliably. That was enough. Within a year, Baldwin had received 4 more orders. By 1840, Baldwin Locomotive Works had delivered 40 engines. By 1850, that number had grown to 1,500. The factory moved from a small workshop on Minor Street to a huge complex in the Spring Garden District. By 1870, Baldwin was the largest train engine maker in the Western Hemisphere. The scale of production was amazing. Each train engine required thousands of individual parts: boilers, cylinders, driving wheels, valve gears, fireboxes. Every part had to be made to measurements measured in thousandths of an inch. A single mistake could derail a train carrying 200 passengers. Baldwin's workforce grew with demand. By 1900, the company employed over 8,000 workers. By 1920, that number had doubled. These were not just numbers. These were men, many of them immigrants, working 10-hour shifts, 6 days a week. They spoke Polish, Italian, German, Irish. The factory floor sounded like a map of Europe. Their work was brutal. Foundries operated at temperatures exceeding 2,500 degrees Fahrenheit. Molten iron was poured into sand molds weighing several tons. The air was thick with coal dust and metal shavings. Accidents were common: burns, crushed hands, hearing loss from the constant hammering of steam-powered trip hammers. But they built train engines that moved the world. By 1914, Baldwin Locomotive Works had produced over 35,000 engines. They pulled freight across the Rockies. They hauled coal from Appalachian mines. They carried passengers from New York to San Francisco. The company's catalog offered over 300 different train engine designs, each made for specific terrain, cargo, and speed requirements. Then the world went to war. When the United States entered World War I in April 1917, the federal government took direct control of the nation's railroads under the United States Railroad Administration. The reason was simple: logistics. Moving 2 million troops along with weapons, food, fuel, and medical supplies required a coordinated rail network operating at maximum capacity. Baldwin was ready. The company had already been supplying train engines to Allied nations since 1914. Now production shifted entirely to the war effort. The factory ran 24 hours a day. Workers were told their shifts were extensions of the front lines. If a train engine was delayed, soldiers died. Between 1917 and 1918, Baldwin produced over 5,500 train engines for military use. These were not passenger engines. They were heavy freight haulers designed to pull artillery, ammunition, and armored vehicles across the European theater. Many were shipped directly to France, where they operated on battlefield rail lines within miles of active combat zones. According to documentation held by the Smithsonian's National Museum of American History, Baldwin's wartime train engines were critical to the success of the Meuse-Argonne offensive in late 1918. Over 1.2 million American troops advanced through northeastern France, supported by a supply chain that depended entirely on rail transport. Baldwin engines hauled 90,000 tons of ammunition and supplies per day during the offensive's 47-day duration. The war ended. The workers returned to peacetime production, but the machinery didn't stop. By 1920, Baldwin had delivered its 50,000th train engine. Then came 1929. The stock market collapsed. Demand for new train engines vanished overnight. Baldwin's workforce shrank by half. The factory, once operating at full capacity, fell silent for weeks at a time. Orders dried up. Smaller competitors went bankrupt. Baldwin survived, but barely. The Great Depression tested every industrial company in America. For Baldwin, survival meant reinvention. The company began producing diesel-electric train engines, a new technology that promised greater efficiency and lower operating costs compared to steam. But steam was Baldwin's identity. Diesel felt like surrender. By 1939, Baldwin had laid off thousands of workers. The Spring Garden Complex, which once employed 20,000 men, now operated with fewer than 8,000. The factory's main assembly hall, capable of building 12 train engines at the same time, stood mostly empty. Then the world went to war again. On December 7, 1941, Japan attacked Pearl Harbor. 2 days later, the United States declared war. Within weeks, the War Production Board issued orders to every major industrial manufacturer in the country. Baldwin Locomotive Works received its directive in January 1942. Produced train engines for military transport at maximum capacity. There would be no delays, no excuses. The workforce returned. Many were the same men who had built train engines during the First World War, now in their 50s and 60s. Their sons joined them. Women, previously excluded from factory work, were hired by the thousands. According to records from the Pennsylvania Historical and Museum Commission, women made up nearly 30% of Baldwin's workforce by 1943. They operated lathes, welded boiler plates, and assembled valve systems. Production accelerated. Baldwin built train engines for the U.S. Army Transportation Corps, the Soviet Union under the Lend-Lease program, and allied nations across Europe and the Pacific. Between 1942 and 1945, Baldwin produced over 6,000 steam train engines specifically for wartime use. These were not standard freight engines. They were purpose-built machines designed for military logistics. The S-160 class, for example, was a standardized 280 configuration train engine optimized for rapid deployment. It could be taken apart, shipped overseas in sections, and put back together in field workshops near combat zones. Over 2,100 S-160 train engines were built by Baldwin and other contractors during the war. Each S-160 weighed 176,000 pounds without fuel or water. Its driving wheels measured 57 inches in diameter. It generated 31,490 pounds of pulling power, enough to haul a 1,500-ton freight train across flatland or a 600-ton train up a 2% grade. Fuel capacity was 22 tons of coal. Water capacity was 6,000 gallons. These numbers were not random. Every detail was calculated to meet battlefield requirements. Speed, power, and durability had to be balanced against ease of maintenance. A broken train engine in a combat zone could strand an entire supply convoy. Baldwin's engineers designed the S-160 to be repaired by people with little training using basic tools. Parts were standardized and interchangeable. Bearings could be replaced without lifting the train engine's frame. Boiler tubes could be swapped in field conditions. According to post-war analysis by the U.S. Army Corps of Engineers, the S-160's mean time between failures exceeded 8,000 miles, much higher than pre-war civilian train engines operating under similar loads. The manufacturing process required absolute precision. Each train engine began as raw materials: steel plates, iron castings, copper tubing, brass fittings. The boiler alone required over 400 individual rivets, each hand-driven by teams of riveters working in synchronized rhythm, 3 men per team, one heating the rivets in a portable forge until they glowed orange, one catching the rivet with tongs and positioning it in the pre-drilled hole, one driving it home with a pneumatic hammer that shook the entire frame. The noise was unbearable. A single rivet gun produced sound levels exceeding 110 decibels. Multiply that by dozens of riveters working at the same time across the factory floor. Hearing loss was not a possibility. It was guaranteed. Most workers were partially deaf by age 40. Some were completely deaf by 50. Hearing protection didn't exist. The only defense was distance. But distance meant slower production, and slower production meant soldiers dying overseas while waiting for supplies. So the riveters stood close, and they went deaf, and the train engines got built. The women who entered Baldwin's workforce during the war faced additional challenges. They were paid less than male workers, typically 60 to 70% of equal male wages. According to labor records from the period, they were assigned to lighter tasks: assembly line work, painting, electrical wiring. But lighter did not mean easier. Many tasks required standing for 12-hour shifts without breaks. Bathroom access was limited. Child care was non-existent. One woman, whose name appears in oral history saved by the Pennsylvania Historical Commission, described her experience this way: "I worked painting train engine cabs. The fumes made me dizzy. I vomited twice a day, every day for 6 months, but the pay was better than anything else I could find. My husband was overseas. My children needed to eat, so I kept painting." That was the math of wartime production. Not heroism, not patriotism. Survival. By mid-1943, Baldwin was producing an average of 12 train engines per week. That meant 12 boilers, 48 driving wheels, 144 cylinders, 600 valves, thousands of pipes, gauges, fittings, and fasteners. All made, assembled, tested, and shipped within 7 days. The logistics of such production required military-level coordination. Raw materials arrived by rail from steel mills in Pittsburgh, copper mines in Montana, and coal fields in West Virginia. Finished train engines departed on the same rail lines headed to ports on the East Coast for shipment overseas. The factory operated as a continuous flow. Materials in, machines out, day after day, month after month, year after year. Mistakes were rare, but catastrophic. A single mistake in boiler design could result in an explosion, overpressure, structural failure, death. Baldwin's quality control inspectors checked every weld, every rivet, every valve. According to company records, rejection rates during wartime production averaged less than 2%. That's 98% of train engines built to specification under huge time pressure in dangerous conditions. The men and women who achieved that level of precision were not engineers. Most had no education beyond elementary school. They learned through repetition, through watching experienced workers, through making mistakes that cost them fingers, hearing, and years of their lives. And they built train engines that won wars. The human cost of this production was huge. Factory workers at Baldwin operated in conditions that would be considered unbearable by modern standards. Shifts lasted 12 hours. Breaks were minimal. The factory floor was a landscape of molten metal, deafening noise, and constant danger. Injuries were frequent. Burns from molten iron, crushed fingers from misaligned machinery, breathing damage from inhaling coal dust and metal particles. According to Union records saved by Temple University's Urban Archives, Baldwin reported an average of 15 workplace injuries per week during peak wartime production in 1943. Many workers were sent home with partial disability. Some never returned, but they kept building because the alternative was unthinkable. By 1944, Baldwin train engines were operating on every major front of the war. In Europe, they hauled supplies from Normandy beaches to frontline positions during the Allied advance into Germany. In the Pacific, they transported ammunition and fuel across islands captured from Japanese forces. In the Soviet Union, Baldwin engines delivered under Lend-Lease moved Red Army divisions toward Berlin. The scale of Baldwin's contribution is hard to overstate. According to data compiled by the U.S. War Production Board, train engines built by Baldwin and other American manufacturers moved over 90% of all military freight transported by rail during World War II. Without them, the supply networks that kept Allied forces going would have collapsed. The war ended in August 1945. Baldwin's wartime contracts were canceled within weeks. The workforce, which had grown to nearly 20,000 during peak production, was cut in half by the end of the year. Many workers returned to civilian life. Others were laid off permanently. The factory that had run 24 hours a day for 4 years fell quiet. Peacetime brought new challenges. Diesel-electric train engines, which Baldwin had resisted during the 1930s, now dominated the market. They were more efficient, required less maintenance, and didn't need water stops and coal refueling. Steam, once the foundation of American railroads, was becoming outdated. Baldwin struggled to adapt. The company had built its reputation on steam power. Diesel technology required completely different engineering knowledge. By 1950, Baldwin was losing market share to competitors like General Motors' Electromotive Division and the American Locomotive Company, both of which had invested heavily in diesel development before the war. The shift happened faster than anyone expected. In 1945, steam train engines accounted for 95% of all mainline rail power in the United States. By 1955, that number had dropped to 30%. By 1960, steam was effectively extinct on American railroads. The change took 15 years. Baldwin, with over 100 years invested in steam technology, couldn't change fast enough. The company tried. Baldwin partnered with Westinghouse Electric to develop diesel-electric train engines in the late 1940s. They produced several models: switchers, road freight train engines, passenger train engines. But they were late to market. General Motors had already taken over. Railroads that had purchased GM diesels in the 1940s saw no reason to switch suppliers in the 1950s. Brand loyalty, once Baldwin's greatest asset, now belonged to competitors. Orders declined year after year. In 1950, Baldwin delivered 350 train engines. In 1952, that number fell to 200. In 1954, fewer than 100. The factory designed for maximum wartime production was now operating at less than 10% capacity. Workers were laid off in waves. First, the youngest, hired during the war, then the middle-aged, who had decades of experience, but no seniority protections. Finally, the oldest men in their 60s who had spent their entire working lives at Baldwin. Many left with no severance, no pensions, just a handshake and a final paycheck. Union records from the period described the layoffs as brutal. Men who worked alongside each other for 30 years said goodbye in parking lots. Some cried. Some didn't speak. They collected their tools, walked out, and never returned. The factory that had employed 20,000 workers in 1943 employed fewer than 3,000 by 1955. The neighborhood surrounding the Spring Garden complex, which had depended on Baldwin wages for generations, began to collapse economically. Shops closed. Families moved. Houses were abandoned. In economic terms, this was called market transition. In human terms, it was devastation. Orders declined. The factory's main assembly hall, which had once produced 3 train engines per day, now stood mostly empty. Workers were laid off in waves. By 1955, Baldwin employed fewer than 5,000 people. The company that had defined American train engine manufacturing for over 100 years was dying. In 1956, Baldwin Locomotive Works built its final train engine, a diesel-electric switching engine delivered to a steel mill in Pennsylvania. It was train engine number 70,000. The factory closed shortly after. The Spring Garden complex, which had employed 20,000 workers at its peak, was sold and demolished. The machinery was auctioned off. The workers scattered. Today, Baldwin train engines still exist. Some operate as heritage railways, pulling tourist trains through mountain passes and farmland. Others sit in museums, their boilers cold, their wheels silent. A few remain in industrial service, hauling freight on short-line railroads in developing countries. But the factory is gone. The workers are gone. The industry that built them has moved on. What remains is memory and the knowledge that 20,000 people working in brutal conditions built 70,000 machines that move a nation, that powered 2 world wars, that connected cities and carried armies and made the impossible routine. Baldwin Locomotive Works did not survive the change to diesel, but its legacy lives on in every rail line, every freight yard, every industrial corridor across America. The train engines are gone. The memory of what they carried is not. If this story reminded you that history is built by hands, not just names, consider subscribing. There are more stories like this. Stories that don't get told often enough. According to research conducted by the Railroad Museum of Pennsylvania and the Smithsonian Institution, Baldwin's total production output between 1832 and 1956 exceeded 70,500 train engines. These machines operated on 6 continents. They hauled coal, grain, steel, timber, passengers, and soldiers. They climbed mountains. They crossed deserts. They survived wars. The final number, 70,000, represents more than industrial output. It represents 130 years of labor, generations of workers who entered the factory as young men and left as old ones, immigrants who learned English on the factory floor, women who welded boilers during the war and were sent home when it ended, engineers who calculated stress loads by hand long before computers existed. Each train engine required about 12,000 labor hours to complete from the pouring of the first boilerplate to the final coat of paint. Multiply that by 70,000. The result is over 840 million hours of human labor. That's 96,000 years of measured and continuous work by a single person. But it wasn't one person. It was 20,000 working together, building machines that outlasted their builders. The factory's demolition in 1956 erased most physical traces of Baldwin's existence. The main assembly hall was torn down. The foundry was taken apart. The office buildings were converted into warehouses. The neighborhood that had once depended on Baldwin for jobs slowly changed into a residential area. By the 1970s, few people remembered what had stood there, but the train engines remain scattered across the world, rusting in rail yards, restored to working condition by preservation groups, displayed in museums as relics of an industrial age that no longer exists. One such train engine, Baldwin No. 60,000, built in 1926, still operates on the Strasburg Railroad in Pennsylvania. It weighs 385,000 pounds. It burns 4 tons of coal per hour. It generates 68,000 pounds of pulling power. When it moves, the ground shakes. The sound is thunder turned mechanical. Tourists ride behind it, watching farmland pass by, unaware that the machine pulling them was built by men whose names are lost. Men who worked in heat and noise and danger because the alternative was starvation. Men who built train engines not because they loved trains, but because they had families to feed. That is the truth Baldwin Locomotive Works represents. Not innovation for its own sake, but survival through labor. Not progress as something abstract, but progress as a paycheck. Week after week, year after year, until the work ran out. By the time Baldwin closed, the company had outlasted most of its competitors. The Schenectady Locomotive Works, the Pittsburgh Locomotive Works, the Richmond Locomotive Works, all gone, all absorbed by larger companies or shut down entirely. Baldwin survived longer than any of them, but survival is not the same as victory. The change from steam to diesel was unavoidable. Steam train engines required constant maintenance. Water stops every 100 miles. Coal refueling every 200 miles. Boiler inspections every 30 days. A crew of 3, engineer, fireman, and brakeman. Diesel train engines required less of everything. Fewer stops, smaller crews, lower operating costs. Economics, not technology, determined survival. Baldwin understood this. The company produced diesel-electric train engines starting in the 1930s. But diesel was never Baldwin's strength. The company's identity was rooted in steam. When steam died, Baldwin died with it. The human cost of that death is harder to measure. 20,000 jobs lost, families displaced. Some found work at other factories. Some retrained for different industries. Some never worked again. The economic disruption caused by Baldwin's closure rippled through Philadelphia for decades. According to labor historians at Temple University, the Spring Garden neighborhood experienced a 40% drop in median household income between 1956 and 1970. Property values collapsed. Businesses closed. The community that Baldwin had built slowly broke apart. That is the cost of industrial progress. Not just machines made outdated, but people made outdated alongside them. Yet Baldwin's contribution to American history cannot be dismissed. The company built the train engines that connected the Transcontinental Railroad, that hauled steel for skyscrapers, that moved troops during 2 world wars, that powered the industrial expansion of the 19th and 20th centuries. Without Baldwin, America's railroad network would have developed more slowly. Cities would have remained isolated longer. The supply systems that kept military campaigns going in Europe and the Pacific would have been weaker. The industrial strength that allowed America to become a global superpower would have been smaller. Baldwin Locomotive Works was not perfect. The company fought labor unions for decades. Working conditions were dangerous. Wages were often too low. But the train engines were real. The labor was real. The contribution was real. And that contribution was built by 20,000 workers whose names are mostly forgotten, whose faces exist only in faded photographs saved by historical societies, whose labor built machines that outlasted their builders. If you've stayed with this story to the end, thank you. History is not just what famous people did. It's what ordinary people built. If you want more stories like this, subscribe. These stories matter. The final train engine, number 70,000, rolled out of Baldwin's factory in 1956. It was a diesel-electric switcher painted blue and yellow, headed for a steel mill in Pittsburgh. It weighed 240,000 pounds. Its engine generated 1,200 horsepower. It could pull 3,000 tons at 15 miles per hour. It was unremarkable. Just another train engine. Just another machine. But it was the last one. The end of a 124-year history. The final product of a company that had built more train engines than any other maker in American history. The workers who built it knew the factory was closing. The orders had stopped. This was the end. They'd built it anyway, with the same precision, the same care, the same attention to detail that had defined Baldwin for over 100 years. Because that's what builders do. They build even when they know the building is over. Baldwin Locomotive Works closed in 1956. The factory was torn down. The workers scattered. The industry moved on. But the train engines remain. 70,000 machines scattered across the world, carrying the weight of history, not because they were exceptional, but because they were built by people who showed up, who worked, who endured. That is Baldwin's legacy. Not innovation, not genius, just labor. 20,000 people building 70,000 machines, one at a time, for 124 years. The factory is gone. The train engines endure. And somewhere on a heritage railway or in a museum or on a remote industrial track, a Baldwin train engine still moves, still hauls, still works. Because good work lasts longer than the people who did it. The story of Baldwin Locomotive Works is the story of industrial America, not the story told in boardrooms or history books. The story told in welding sparks and coal dust, in 12-hour shifts and crushed hands, in train engines that crossed continents and carried nations to war. It's a story worth remembering, not because it's comforting, but because it's true. If this story meant something to you, share it. Let others know what Baldwin built. Let them know who built it. History isn't just events. It's people. And the people who built Baldwin deserve to be remembered. The train engines are still out there, silent, rusting, waiting. But they're there. 70,000 reminders that 20,000 people once built something that mattered. And that's enough.